between curves. So this is our last topic. So we've done area under a curve to the x-axis. But more interesting is when both bounds of your shape have unusual areas. So that's what we're working with here. So definition, well, let's just look at the picture. What you're going to do is you're basically going to integrate the top minus the bottom. So previously, your bottom would have been the x-axis. X-axis, though, as a function is just y equals 0. So that didn't actually do anything. So why do we have to worry about it? We just integrated the function. Now, what we're going to do is we're going to integrate the top function minus the bottom. So always think top minus bottom. To do this, you have to figure out who the top function is. It's not going to tell you in most cases. You have to look at your picture. So if we read our picture here, the blue curve is our top function. Why? Because no matter where we are on our shape, that is the highest point in any given x value. Take an x, the highest point on our curve, the highest point in our shaded area would be the blue. The yellow is the lowest point for any particular x value. So we're going to make some notes here. Let's see, the blue curve is 2 minus x, so this is our top. And the bottom is a straight line, negative x. So when we go to integrate, our area is the top, 2 minus x squared, minus the bottom, which was a negative x, is. Then what you have to figure out is your limits of integration. So we need the furthest to the left. The furthest to the left is this point. So this is at x equals negative 1. That's going to be our first limit of integration. And then the furthest to the right point in our shaded region is this point, which is at x equals 2. So that's our upper limit of integration. Sometimes those are not going to be obviously stated on your picture. So how would you find it if the picture did not tell you? Well, look what's happening at these points. Two curves are intersecting. So that what you would do to find your limits of integration is you would set the two curves equal to each other, meaning that they intersect, and then you would solve that problem. So I'm going to bring my x squared around. I'm going to bring my 2 around. And go to change sign. So the factor on the right, so negative 2 and positive 1. That would be x equals negative 1 and positive 2. Those are your limits of integration. You do it in numerical order. Because we're looking for area. There's no reason to go backwards. Now, we can finish our problem. We can simplify. These two negatives become positive. So we're really integrating. Let's see. Let's put it in order. So negative x squared plus x minus 2 dx. This is what we're really integrating to find the area. So negative 1. Alright, antiderivative. So negative x to the, add 1 to the power, so 3, multiplied by the reciprocal. Add 1 to the power, so 2, multiplied by the reciprocal, minus 2x. Negative 1, positive 2. Alright, plug in 2. So that would be 2 cubed, so that would be negative 8 over 3. Plug in 2, so 4 times a half would be plus 2. And then 2 times 2, that would be negative 4. So that's what I get if I plug in 2. Minus, if we plug in a negative 1, that would be negative 1 cubed is still negative. And then negative 1/3 makes it positive 1/3. Negative 1 squared, positive, so that's positive 1/2. And then negative 1 times negative 2, positive 2. Whew, that was fun. Alright, we got fractions, we got stuff to simplify. So these two become a negative 2. Let's just copy all that. So negative 8 over 3 times 2. And then all these change to negative. We can distribute that negative. Negative distribute. We can combine together common denominators. And we can combine together the negative 2. So negative 8 over 3 minus 1 over 3. That means negative 9 over 3. Yay, it reduces. And then the negative 2's make negative 4, and then we have the negative 1/2. That's that's negative 3 minus 4 minus 1 half, or negative 7 minus a half. Common denominator, 7 over 1, that's going to be negative 14 over 2 minus another half, or negative 15 over 2. There you have it. That's the area. Wait. I have the area negative. What happened? Top minus bottom. Oh, I got my signs wrong. So it should have been negative x squared plus x plus 2. That's my problem. That right there. Plus. Let me fix it. So plus. Plug in 2, that's going to be plus. Darn it. And plug in negative 1. And do minus. I'm sorry. Minus. Now I gotta fix all this. Why you should always be slow and careful. I probably could have fixed it, but I had to do some new stuff. Why I need y'all here? We've been doing that. I like that every time. This is true. Hard to see everything on when I'm trying to scroll up and down. Alright, then I fix my signs. So if I plug in 2, I get 4. If I plug in 1, I get 8. Alright, so let's figure out what this is. So negative 8 over 3 plus 6 minus 1/3 minus 1 half. Plus 2. So that these two I can put together. These two I can put together. So it'll be negative 9 over 3, or negative 3. 6 and 2 make 8. Minus 1 half. Negative 3 and 8 make 5. Minus 1 half. 5 is over 1. The common denominator, top and bottom. So that is 10 over 2 minus 1 over 2, which is 9. There we go, positive. So, you get a negative area. You did something